As humanity continues to gaze upward at the vast canvas of the night sky, we often think of the stars above as fixed and eternal, quiet witnesses to the passage of human history. Yet even in that apparent stillness, profound changes are unfolding. Changes that could alter the very face of the heavens within our lifetimes. Among these possibilities, none is more captivating or unsettling than the potential transformation of Polaris, the North Star. For centuries, the singular point of light has guided travelers across oceans, deserts, and uncharted lands, serving as both a practical beacon and a profound symbol of stability. Now, subtle but significant signs suggest that Polaris may not remain unchanged forever, and that its role as our steadfast compass in the sky may be approaching a dramatic turning point. Polaris has long occupied a unique place in the human story. Situated in the constellation Ursa Minor, its nearly fixed position above Earth's northern axis has made it an invaluable marker for navigation. Long before compasses and GPS, mariners steered their ships by its steady glow, and nomads crossing barren deserts oriented themselves beneath its unwavering presence. To the naked eye, it appears as a moderately bright yellow-white star, but closer study reveals that it is far more complex. Polaris is not one star, but a triple system. Polaris AA, a massive supergiant, Polaris UB, a closely bound companion, and Polaris B, a more distant partner orbiting the central pair. These gravitational interactions create delicate influences on brightness, pulsations, and motion that astronomers continue to study with fascination. The complexity of this system means that Polaris is not quite as constant as it once seemed, and its behavior has become a source of both mystery and speculation. At a distance of roughly 323 light-years, the light we see from Polaris tonight actually left its surface more than 3 centuries ago, long before telescopes became widespread. This built-in time delay complicates our understanding of the star's true state. If Polaris were to undergo a cataclysmic event today, perhaps exploding in a brilliant supernova, the evidence would not reach us for centuries. Some scientists even allow for the possibility that Polaris may already have changed in ways we have yet to witness. A sobering reminder that much of astronomy is a study of history written in starlight. The notion that our guiding star could already be gone, its fate still hidden from us by the gulf of distance and time, forces us to grapple with the limits of knowledge in a universe that reveals itself only gradually. Throughout history, Polaris has been more than just a celestial landmark. Its constancy elevated it into the realm of myth and metaphor. Ancient cultures woven into stories of guidance, permanence, and divine order. Mariners described it as a cosmic anchor, a fixed point in a sky that otherwise seemed in perpetual motion. Even in modern times, its symbolism endures. It appears in literature, poetry, and philosophy as an emblem of faithfulness, direction, and truth. Yet in recent decades, this reputation for steadfastness has come under challenge. Astronomers monitoring Polaris have detected subtle anomalies in its pulsations, variations in brightness that were once strikingly predictable. Instead of the steady rhythm scientists expected, the star has shown erratic behavior, its pulsation period lengthening by about 4.5 seconds, a small but significant change in astrophysical terms. These irregularities hint that Polaris may be entering the final stages of its life cycle, advancing toward transformations that could culminate in a spectacular end. The comparisons to Betelgeuse, the red supergiant in Orion, are hard to ignore. Betelgeuse famously dimmed in 2019 and 2020, igniting speculation that it might soon explode in a supernova. While Betelgeuse received intense attention from scientists and the public alike, Polaris has remained more quietly enigmatic. Its change is subtler, yet no less intriguing. Both stars are in advanced stages of stellar evolution. Both exhibit unexplained variability, and both challenge existing models of how massive stars live and die. The prospect of Polaris undergoing a supernova has stirred debate among astronomers. While many caution that such an event may still be far in the future, the evidence of irregular pulsations and internal instability keeps the possibility alive. Should Polaris ever explode, the spectacle would be breathtaking. From its position in our sky, a supernova would not pose a danger to Earth given its distance. but its brilliance would dominate the heavens. For weeks or months, it could shine, as brightly as the full moon, visible even in daylight, its radiance casting shadows at night. Constellations like Ursa Minor would be dramatically altered, reshaping the sky we have known for millennia. The cultural and symbolic loss would be profound. For generations, Polaris has been more than a star. It has been a metaphor for certainty, constancy, and guidance. Its disappearance or transformation would be a stark reminder of impermanence, a cosmic lesson that even the most seemingly eternal lights in our sky are subject to change. Astronomers approach this possibility with both excitement and humility. A Polaris supernova would provide a once-in-history opportunity to study stellar death in remarkable detail. The elements forged in the star's fiery end, carbon, oxygen, iron, and others would be expelled into space, seeding the galaxy with the raw materials of future stars, planets, and perhaps life itself. In this sense, even destruction carries within it the promise of renewal. Stars do not simply die. They give birth to new possibilities, their ashes becoming the building blocks of cosmic evolution. Polaris in this light would not merely vanish, but would contribute to the ongoing cycle of creation that defines the universe. Yet for all the scientific potential, the human dimension cannot be overlooked. The end of Polaris as the North Star would reshape how we relate to the sky. Navigators of old would lose their symbolic guide. And while modern technology renders celestial navigation less essential, the cultural resonance of Polaris remains powerful. To lose it would be to lose a shared point of reference, a link to our ancestors who once looked up and found their way by its glow. It would mark the closing of a chapter in humanity's relationship with the cosmos. The story of Polaris also reminds us of the layered complexity of astronomy itself. For early observers, it was a singular point of light, a gift of orientation. With better telescopes, we discovered it was not a solitary star, but a dynamic system of three. With spectroscopy and precision measurements, we uncovered its pulsations and irregularities. Each new layer revealed more depth, more uncertainty, and more connection to the processes that govern all stars. Today, scientists study its shifts not simply to understand Polaris itself, but to test broader theories of stellar physics, mass, loss, and evolution. Its peculiarities could offer insights applicable across the galaxy, teaching us about the fates of stars that share its mass and structure. But beyond the technical, the unfolding tale of Polaris speaks to something deeply human. We search the stars for guidance, for meaning, for constancy. In a world that is always shifting beneath our feet, Polaris, steady in our skies, has been a mirror of that yearning. Now, as it shows signs of instability, we are reminded that nothing is truly permanent, not even the brightest beacons of orientation. This realization forces us to confront the fragility of permanence itself, the transience that underlies all things. If Polaris one day bursts into brilliance and fades from our skies, it will not only be a scientific milestone, but an existential moment for humanity, a reminder that even our most trusted symbols are part of a universe defined by change. And yet there is beauty in that recognition. To watch Polaris closely, to debate its fate, to prepare for its possible end, is to engage in a dialogue with the cosmos itself. Our ancestors may have trusted it without question, but we now peer into its secrets with instruments capable of detecting minute fluctuations, seeking to understand what it tells us about its inner workings. This act of observation connects us to a tradition stretching back millennia, linking the navigators of the past to the scientists of the present and the dreamers of the future. Ultimately, whether Polaris continues to shine as our northern sentinel for centuries more, or whether it astonishes us with a sudden fiery demise, its story is already deeply entwined with ours. It embodies our search for meaning in the stars, our attempt to balance constancy with change, our struggle to find stability in an ever-evolving cosmos. Its future, uncertain as it may be, is a reflection of our own journey, a reminder that permanence is an illusion, and that in both the heavens and our lives, it is the process of change itself that defines the story. Polaris has guided us across oceans and deserts, across generations and civilizations. Now it guides us inward, toward a deeper understanding of impermanence, resilience, and the unbroken cycle of creation that binds us to the stars. The story of Polaris is not only one of stellar physics and cultural mythology, but also of time itself. Its role as the North Star is not eternal, even without the possibility of a supernova. Earth's axis wobbles slowly in a motion called precession, completing a cycle roughly every 26,000 years. This gradual shift means that the identity of the North Star changes over millennia. In ancient Egyptian times, the role was held by Thuban in the constellation Draco. Thousands of years into the future, Vega and Lyra will take its turn as the guiding star. Polaris is simply one stop.